Hello, everybody. Welcome. My name is John Carson. I'm a technical account manager with AWS. In this session, we're going to review a proactive approach for assessing workload resiliency. We're going to say why that's important. We're going to review our methodology. We're going to see a demo, and we'll take questions at the end. I'm co-presenting today with Padmakar. Padmakar, if you want to introduce and kick us off.
Appreciated that. Thank you, John. Hello, everyone. My first name is Padmakar. Last name is Bhosale. I'm designated TAM for global payment. I have my customer here. So today's presentation, let's start with the problem statement. And problem statement actually stemmed from the survey across 2,100 industry leaders with 7 key industries. And what it reveals, it's a lack of resilience awareness among 80% of organizations. 50% of them are not ready to face any challenging disruptions that come from outages. That hinders actually their ability to maintain critical workloads as well as their operation. And it's not only that, 20% though have advanced resilience posture. It's the nature of outages and their impact on workloads are pretty dynamic, and it is evolving ever. Any static resilience corrective actions or resilience solution not necessarily been able to or efficient enough to handle or to sustain any impact coming from the modern outages. And as we know, customer impacts raise hand in hand with downtime, and any extended downtime risk, financial stability, hamper loss of productivity, as well as your customer retention also. Across Fortune 1000 companies, on an average, it is 100K loss per hour for outages. And if you take top 3 organizations, top 3 outages, revenue loss is around 53%, loss of productivity is around 47%, and loss of brand equity is around 41%. And then talking about brand equity, if any repeated event actually inflict slow repair reputation damages. So what we recommend through today's presentation is organization to reassess their resilience strategy and adopt proactiveness. So proactiveness actually, there are major aspects of proactiveness is anticipation, embracing resilience, and preparedness. As Dr. Vogel, advocate, CTO of Amazon.com, that everything fails all the time, and we need to embrace resiliency. In order to be proactive, resilience has to be by design. Resilience has to be continuous, because if you have any static solution, that static solution not necessarily been ready to ever evolving modern outages. Right? So in today's session, we are going to take some guiding principle. Guiding principles are proactiveness by design, anticipation failure points, and process of improvement. And in today's session, we will be speaking about what to anticipate. What are the tools or method that can be utilized to anticipate? We are going to see that your organization past event, any assessment around resilience, and threat modeling would help us to anticipate where area within your workload could fail in future. However, before we go further, let's try to understand shared responsibility model. In today's session, we will be speaking what's there in the cloud. You as a customer, your workloads that is running on AWS platform, that you will be responsible for any proactive recommendations that we are presenting it here.
So we've talked about building resilient workloads, why that's important. Those come with challenges though, right? To proceed with it.
Yep.
Okay. And part of those challenges is identifying the resiliency risk and faults, right? So our workloads have a number of services, number of resources. How do we easily identify those resiliency risks to meet our RTO and RPOs? That's what part of our approach is going to talk through today and address multiple of these challenges. Oh, okay, got it. So really it's a 6-step approach. In step 1, we'll profile the critical workloads. In step 2, we'll assess those workloads with Resilience Hub, and we'll actually have a demo of that towards the end. In step 3, now that we assessed with Resilience Hub and assessed against RTO and RPOs, we'll start looking around the corners and thinking about different threats. We'll think about chaos engineering, plan some experiments. In step 4, we'll actually use fault injection service for those experiments. And again, this is included in the demo towards the end. And in step 5, we'll measure and remediate and improve our work sets. And in step 6, we'll repeat. In the first step, we'll profile our workloads. Part of this profiling is collecting both business and technical information. We'll want to understand the business units, the business purpose of those workloads. We'll also want to understand some of the core components of the technology side, like whether it's multi-AZ, multi-region. And this is really collecting information and starting to use as a base data store for collecting those workload information so we can assign RTO and RPOs. One important aspect here in collecting the profile information and assessing risk is making sure that our business goals really drive our workload criticality objectives. So business really drives the technology. Technology doesn't drive the business, right? So for RTO and RPOs, we're going to need to get down to understanding business risk. What happens if that goes down? We're going to have financial loss. We're going to have reputational loss, those types of things. And again, we'll talk about those financial losses, those regulatory compliance possible issues, reputational impacts, and we'll actually include those assessments and those risk levels in our profiles. We'll then want to group those workloads into tiers. So if you think about all the workloads and applications you have, way too many to have individual RTO and RPOs, right? So you want to group those into into tiers, and then with each tier rating, you want to assign RTO and RPO, so you can really assign architectural requirements, guidelines for monitoring, and also resiliency assessments for each tier. So it's really about grouping your workloads into tiers and then assigning the assessments per each tier. And then, so step 1 is done. We profiled our workloads. We looked at the business side. We looked at the core technology side. We understood the risk. We did business impact analysis, understood the downtime requirements and uptime requirements and what happens if it's down. We're going to have financial loss. We're going to have regulatory problems. We're going to lose customers. We'll now take that information and assign RTO and RPOs and then run Resilience Hub against those. So Resilience Hub is a service that will take RTO and RPOs, and we'll see this in a demo, but it'll take RTO and RPOs, run that against your resources, and tell you whether those resources are going to meet RTO and RPO requirements you define. And it's really a 3-step process. You assess it in the tool. It outputs resilience recommendations as well as operational recommendations. And we'll see this, but operational recommendations being given include alarms, SOPs, which are standard operating procedures, and even fault injection experiments that are out of the box, or you can create your own. Understanding after we did step 2, we now profile our applications. We ran Resilience Hub. We cycled through that. We met our RTO and RPOs. Now it's time to start looking around corners, thinking about different threats, and using chaos engineering with our fault injection service. So there's different types of threats out there. We could have code deployment problems, could have infrastructure problems. But one thing we're going to look at now in more detail is dependency analysis.
So dependency is very common across most of the workloads, across different industry, different workloads. And that's the reason we have taken dependency modeling as the example here. You can do actually threat modeling across all this pattern that you see on the screen. So let's deep dive into dependency modeling. So the first approach of dependency modeling is to break down your workload into different components. This breakdown could be output of your architectural assessment, could be output of your risk modeling or a risk management. It could be it could be outputted from any other technical assessment that you do that. The idea of breaking down your component, your workload into various components is to classify them as per their resilience posture. Their individual components may have their own resilience requirement. So you go from workload to component level so that you can granularly manage those components. And every component, the idea is it can be deployed by itself. So for example, in your 3-tier application, you might have front end, your business logic, as well as your database, right? So it's a very simple example. Your database layer could be deployed in any region AZ independently so that you can have a business continuity. So it's the same concept being applied here to break down your workload into multiple components and define each component's resilience posture, current resilience posture, as well as tiering system, which gives you what is this required resilience posture. Plus, it gives you criticality. So in case of any service outages, you can actually prioritize what, based on criticality, what are those components has to be up and running, and you can deploy them, have corrective actions been applied. Right? Going deeper into dependency framework modeling is to identify internal and external dependencies too. On the screen, you see internal dependency. So how those components depend on each other, and how if something goes wrong with one component, how that component would affect other component too. For example, component 9 depend on component 10, right? If component 10 is actually a tier 3 service, tier 2 service actually is not critical too. But if component 10 goes down, reliability of component 9, which is critical, would be impacted, right? So that's a reading you can read from your internal dependency framework. Going to external dependency framework, similar component being now landscape in a manner that you can identify those components. What are those services from AWS side? What are those services which is deployed in AWS cloud, however, been supplied by a vendor or marketplace solution, as well as whether you have high availability across your multiple AZs, high availability across region. You can actually have those dependency, external dependencies documented and have this landscape ready. The main output out of your dependency framework gives you a scope of your impact. Again, if something goes wrong tomorrow, what are those components would get affected because of certain services being not available, right? So that's one of output. another output is it gives you where your workload would have potential weakness. For example, all these components depend on SQL services, right? So from AWS side, if tomorrow SQL service has some impairment, you can figure it out. All these components would get affected. And based on criticality, you can actually decide what corrective actions you want to do that to have your services up and running to protect your business, right? So we're going to take this example and build FIS hypothesis, failure hypothesis, right? So as you see, component one depend on two regions, depend on two AZs, right? So we can take a network failure as hypothesis. What if my network tomorrow goes down? What will happen to on my components, right? So that's a hypothesis. With FIS provide you out of box FIS experiment. You can take those experiment. Multiple experiments are available. Here I have taken 3 examples, such as what if because of network your data replications impacted? What if a power failure could impact your AZ availability, right? So you can have these experiments borrowed from FIS out of box and then simulate your network failure using FIS experiment. You can learn how your workload or a particular component experience behaves in a simulated manner, in a controlled manner, and you want to run this FIS experiment in your non-production environment so that you can you can see how again those workloads react to those simulated events. You can get report out of AWS Resilience Hub, your FIS experiments, your how your RTO and RPO in how your RTO and RPO factors, as well as your resilience score too, so that you can take this learning, correct any resilience gap that has been identified through experience, and then have tabletop exercise run it again. So I mentioned tabletop exercise is actually a periodic execution of your failure hypothesis. And then you could have tabletop exercise, maybe running every 15 days, monthly, quarter, based on how aggressive you would like to correct your resilience posture. The idea is whenever you run your tabletop exercise and have corrections been made or done, your resilience posture would improve eventually, right? And that's how you can narrow down your resilience gap for that particular component or multiple component, and ultimately it resulted into a resilience improvement of your workload.
Good, thanks, Pad. So the AWS fault injection service that was being talked about. So if you think about where we're at, we profiled our workloads, we ran Resilience Hub, we did our threat analysis, we identified the FIS experiments and ran them, but just to level set on fault injection service, it really can simulate a range of failures, hardware failures, software failures. And as Pat said, it's really about injecting faults into your services so you can see the reaction of your applications and workloads. On what FIS experiment is, it's made up of 3 parts. It's really made up of targets, actions, and stop conditions. Targets are the resources you're going after. Actions are the actions going to be performed, 1 or more on those targets. And then you have your stop conditions, which serves as guardrails for conditions to stop the run of the FIS experiment. FIS comes out of the box with a lot of different functionality. Some are listed here: kill processes, container instance terminations, database stops, things like that, and that's all out of the box. On measure and remediate for step 5, we'll talk about disruption type analysis. So really this is going through and analyzing the type of disruptions that occurred, whether we achieved our RTO and RPO, as well as our resilience score in running those fault injection experiments. So you think about the hypothesis, running the experiment, verifying, and then looking to improve and modifying your workloads to achieve a higher RTO and RPO for resilience. And to kind of put this all together, you really think about past events, risk assessments, threat modeling as inputs to this process. You're going to have input that into the Resilience Hub. You're going to run your Resilience Hub through multiple times, correcting things until you meet your RTO and RPO and implement those improvements. And once you have that, you can start running FIS experiments, defining those experiments, running them, and again, implementing those. And this should be a continuous cycle as defined by your tier ratings. Your tier ratings may say, hey, resiliency needs to be tested every so often along with DR. But really what we're going to want to do is start shifting left and getting those into the CI/CD pipeline for automation. Our call to action, so what we talked through here was an approach you can start implementing today to test your resilience and improve that. But the call to action is really to contact your technical account manager. Your technical account manager can help you create a resiliency program. If you don't have that now, we can assess gaps in the current program. And again, we can do demos and deep dives on Resilience Hub, fault injection service. And as I mentioned, probably the end result we're shooting for here is really shifting left into your CI/CD pipelines, because both Resilience Hub and fault injection service has APIs. So you can test those with every push, and ultimately that's where you want to be. And you want to get those into your pipeline so those are found before production.
So sometime you as a customer may face some challenges with your bandwidth. Expertise that needed to run some of the recommendations that we presented here. So under enterprise support, we have different entitlements related to resiliency. You can contact your TAM, technical account manager, to leverage some of those entitlements if you needed to.
So I'm going to get out in front here because this is the demo part, and I'm going to have to look through my shoulder. But this is the console experience through Resilience Hub. I'm going to go to an applications and create a new application and show you the experience. You enter the name and description type for your application. You're going to select the resource types and resource collection types. We do CloudFormation stacks, Terraform stacks. We also support EKS only and EKS in collection with resource collections. You're going to select your RTO and RPO. So this is what's created in that profiling stage. You can create new ones or use one you already have built in. So RTO and RPOs come in days, hours, minutes, seconds. It comes for your application as well as your infrastructure, availability zone, and even region. So you can set different RTO and RPOs for those different areas. For permissions, out of the box, we do give you a role, but you need to configure the policy for that, and there's directions on how to do that. It's pretty easy. And you can even schedule daily assessments with drift notification. Drift notification uses SNS. You don't have to do that, though, but you can do that if you want. We're now going to go over to an application that I assessed and look at the assessment and see the output. So when you do Resilience Hub, you publish the application, you run the assessment, and then the output comes the recommendations, and then you run your FIS experiments, and we'll go into these. So under Assessments tab, we see the assessment that was kicked out. We see the policy was breached. So let's go in and see what was wrong. We see on the application side it was unrecoverable. So let's dive down into that and see what went wrong. Both RTO and RPO were breached, and let's see what component was triggering the breach. Looks like it was an S3 bucket. Now, what do we do about that, right? So under resiliency recommendations for policy breaches, it actually gives you detailed recommendations on how to fix that. Gives you 3 options: optimize for cost, minimal changes, or availability zone. It gives you the description, but it also gives you detailed step-by-steps to correct that. So with 3 options here, it's also going to give you the cost difference. So if you're going to increase your cost, it'll give you that. If you're going to save money, it'll give you that. And also give you new RTO and RPOs with the option that you select. So pretty nice. It's giving you detailed steps as well as the effects of those. Under operational recommendations, as I mentioned before, it's going to give you recommended alarms. And to make it easy for you under those recommended alarms, you can just checkbox those, as I'll do here, and you can go over create your CloudFormation templates. Same thing with standard operating procedures, SOPs. You're going to look at the SOPs that is recommending that it didn't see. Going to click those as needed and create CloudFormation templates. And then finally, what we talked about a lot here was looking around the corner, getting the fault injection experiments. Same deal, ease of use. You can just click, and these are all out of the box type things, and you can click your CloudFormation templates and implement those.
So we have a couple of references for you. I would recommend browse those services. You would learn, for example, Resilience Hub would cost you $15 per application per month. However, for 6 months, for 3 applications, first 3 applications, it is free of cost. Another example, FIS, it charges you based on actions. So your one per action, it charges you 10 cents. So for example, if you have experiment having 2 actions runs for 20 minutes and 1 action runs for 10 minutes, your action event would be 50. 50 multiplied by 10 cents, your charges for 20 minutes for 3 actions would be $5. Right? FIS you can run across multiple accounts. Again, I would recommend browse the site, learn how FIS as of today charges for a multi-account experiment to run. With that saying, well, thank you for giving us this opportunity. Please. Yeah, sure.
Application, does it going to automatically discover all?
Yes. So when you add application to FIS, you can actually run. You need to click button to run assessment. It will give you assessment. So there are 2 types of assessment. One is just only on application level. You can have a static assessment. If you're running FIS experiment, you can have a dynamic assessment that includes how your workload behave to that particular failure scenario. So depend on what actions you want to perform, the Resilience Hub would provide you those reports. Sure, absolutely.
Can it be added through the not because you know that our customer doesn't have the policy of no click. So do you have anything?
Yes, right. I got your question. So as John already mentioned, you can actually have automations. FIS as well as Resilience Hub provides you APIs. You can actually put it into your CI/CD pipeline. That's a strongly recommended. You can actually have a script written with multiple FIS experiments that can again be added to CI/CD pipeline and have your automations done. You're welcome.
Yeah, just to emphasize, that's really the end state. I mean, going through the console, learning and using it is great. But at the end of the day, we need to get to identifying faults before they hit production. And that means the CI/CD pipeline. and incorporating this into the pipeline and getting those results before they get to production and get corrected.
Please have your questions coming. I would request if you could complete the survey, provide your feedback. That would be great. Any further questions?
In your multi-step process, step one, collecting the information, do you have any recommendations on how teams can do that? Either a form or a template to collect and send to the business owners? What works well? Having one-on-one conversations about this, or sending out to the business teams that what do you expect your application to being critical in the time that it can be down?
So recommendation is to you to run your business assessment, and business assessment has to be run with your business team as well as technical team. So that's a strongly recommendation. And the reason for that is your business impact would be completely, or under assumption is understood by your business team, and they can drive like what that particular workload is protecting what business, right? And that knowledge has to be, or generally with business. So they drive business criticality, and based on business criticality, your technical criticality can be driven.
Yeah, and just to extend that, I think I agree. It's like you really should form that framework and form that governance model, and then start going out and collecting stuff. And probably a key term in there is business impact analysis, right? Because technology is there to serve the business. So if technology goes down, what's the business impact of that technology going down, which is driving those RTO and RPO discussions, right? So you want to think about the governance model. You want to think about the framework, as you said, of what you're going to collect and what you're going to analyze. And when you think about those risks, really gets down to cost and money, right? So if this goes down, and we highlighted some of those risks, you might have financial risk that you got to pay your clients money back based on their contract, right? You might have reputational impact. You get in the news for being a down and you're losing customers, right? You might have regulatory compliance fines, depending on your business. So having that framework, having that model, but the other thing I'd highly emphasize is having good governance, right? Making sure the compliance model you laid out is actually going to be followed, right? And how's that found out and documented, right? So there's also a blog, we didn't link it in here, but there's a nice AWS blog that actually provides out a step-by-step solution. If anybody's interested, I can get the URL at the happy hour. But what it does is it actually goes into the Resilience Hub, pulls out your assessments and runs a nice quick site dashboard to tell you all the assessments run, who ran what when, and the solutions out there on a blog. So thinking about that governance model, wouldn't it be nice to have that, have a nice quick site dashboard doing a lot of the work for you? So
Thank you.
I think one portion of this question that wasn't answered was the spreadsheets that you showed. Do you have those in a template format?
Yes, we do have that.
Okay.
Yes. In the happy hours, let's connect. We'll supply that to you. We'll try to put it somewhere in common so you can download it. We are actually planning to write a blog post for same, so you might supply through that.
Okay, thank you.
we keep coming back to the happy hour part. So
can we utilize a service like AWS Control Tower to make sure that our technology teams are using the Resilience Hub?
That question probably would go more into your architecture, how you have utilized your control tower or various aspects. Here, what we are presenting is the proactive approach, right? And one of the proactive approaches when you are performing your business impact analysis or architecture review, where this question would come, how your various controls and services actually input into your workload resilience posture, right? And we can take that more question. I know deliberately I did not answer your question because it's very specific and we can have discussion during happy hour.
Yeah, I'm sorry.
Thank you. Again, I'm encouraging you to join happy hour and have more dialogues. Any other question, please? Thank you.
everybody.
One more. I'll steal your mic.
Go ahead.
Sorry, very quick. This is, I'm assuming this, we can use it only for within AWS. If we have workloads which are crossing out of AWS, can we use this?
Yes, you can use that. So I had one slide with external dependency, right? I deliberately specify only AWS services there, but you can actually have, as far as you have connectivity, and you can connect to your on-premises resources or workload or across other cloud provider, you can actually have your external dependency defined, documented, and anticipate where your workload could have weaknesses.
Oh, great. Thank you.
Sure.
There's a lot of good advice out there for managing cyber supply chain.
I think at the broad level, what I've seen in many years is that the dependency analysis is often lacking, right? So we tend to look at our services, we tend to look at those resources. What we tend to miss a lot is that dependency analysis and what happens. And that's when fault injection service can come in and actually do a hit, whereas Resilience Hub is doing really a read. Fault injection service is actually going to go in and touch those resources. So did you have a question too, or no? Anything else? Okay.
And before we conclude, just to emphasize on threat modeling, because your dependency framework and all other modeling will actually give you an input idea where weaknesses could be, and you can actually build your hypothesis. So threat modeling is very key of where anticipation could be.
All right. John and Padmakar, thank you so much.
Thank you. Appreciate it.